Hello friends, welcome to 𝐘𝐥𝐬𝐬 classes. My name is Professor Vivek Singh Rathore and I am Assistant Professor 𝐘𝐥𝐬𝐬 in Government Engineering College, Bilaspur, Chhattisgarh. And I hope you must be safe and your family must be in good position. Uh, See, nowadays lockdown is there in our state also, and maybe in your state also, and the condition is very worse. So I'll suggest you all to be in home and be safe and follow all the COVID guidelines, so that we shall give our best, because if health will not be there, then we cannot focus on the exams and anything. Okay, so or if any of our family member is suffering from some problem, so will not be able to concentrate. So that's why keep safety precautions and be safe. Okay, so in last class, okay, I am taking signals and system subject who are new to the lecture. So I am taking signals and system subject in 𝐘𝐥𝐬𝐬 classes, initiative by 𝐘𝐥𝐬𝐬 faculties. So it has module 1 has been completed, and we are in module 2, that is LTI systems. So in the last lecture we have discussed about many type of in this module we'll be studying about continuous time LTI systems and discrete time LTI systems. What are their properties and how we'll calculate the response and all. So in the last lecture, I think I have discussed about um, how will calculate the response, but I have not solved any question. So let's solve some questions and we'll try to get the actual method what we'll get. So okay, we'll start with the session. So let's suppose our question is there. Let's suppose our question is there that we need to find the response of a LTI system. Okay, so we need to find the response of LTI system. Okay, fine. So okay, we need to find, okay, so what is the input and what is the impulse response. See, I always tell you that it is a impulse response. We are giving an input. Let's suppose xt is the input and impulse response is ht. Okay, so and we'll get output as yt. Why we are taking ht as input? Because I told you earlier also, we are giving input as delta t. When we are giving input as delta t, we'll get by this system only we'll get output as h of t, means so, and as you know, delta t is the identity signal, so ht we can put here. That is why. And what is the use of taking impulse response? That also I will tell you. I'll just hint you, because in Fourier transform we will deal with it. See, delta t, it is in time domain. Hai na? If you take its frequency part, you will get output as 1. Okay, so it means in frequency it is like this. So it is covering all frequencies. That is why for a test means for seeing the response of a system in all frequency, we need to give input as delta t, and we can see that how the system works in all frequency. That is why, and it is an identity signal, so we can put a direct ht here. So finally you can understand that here we are taking input. Why it is taking impulse response? Because when we are giving impulse input, we are getting this output, and this is in the identity signal. So this you can put here also. Okay, and by this convolution we'll get output as yt. That we'll see. So how will get, how will by in question we'll see. So question is given that your xt impulse input x of n will be, let's suppose 4 3 2 1. This is your input, and let's suppose your impulse response will be your, let's suppose 1 2 3 4. This is your impulse response. Now you need to calculate the output. See, first I will try with graphical method, then again multiplication method, and then we'll go for tabular method. by all method we will see how it works, but this is the longest method which I am telling you, but this I am telling because you should know the actual method, how we'll do it, a graphical method. Okay, so for conventional you can try for it. Okay, we'll take solution. See, x of n, as you know, in convolution what we'll change. First step will be change our domain, so x of n will be converted to x of k, and h of n will be converted to h of k. Only domain we need to change. Second step will do what? Will keep the xk same, and will change h of minus k will do. H of minus k will do. Just will do a time reversal. Then third step will be your x of k will be there, and h of minus k plus n we need to do. So we'll do h of minus k minus n like this. So it will come as h of minus k plus n, है ना? So this means we'll need to first we need to shift. Okay, first we need to shift, and then we need to time reversal. Okay, we need to do okay, first we need to do time reversal. First we'll do time reversal here. Okay, and then we'll shift in the right direction. Okay, shift in right direction. Fine. So this will be our step to do in graphical method. How we'll do? Let's suppose we'll take x of k. X of k will take as this value. 4 3 2 1 was there. So this is our 4 3 2 and 1, and here value is n is equal to 0 1 2 3. This value is there. This is your x of k, है ना? X of k. H of k, if you will plot, you will get h of k is 1 2 3 4 na. So 1 2 3 and 4, 1 2 3 and 4. N is equal to 0 1 2 3. Okay, so this is your h of k. Now you need to do what? H of minus k. So h of minus k you will do. So what we'll do? Just we need to time reverse it. Just rotate across y axis. So you'll get 1. So we'll get here, but 2 you'll get here, 3 will get here, 4 will get here, 2 3 4, 0 minus 1 minus 2 and minus 3. Okay, and then what you need to do? You need to time shift. How much time shift? It depends upon how much you are taking. So what we are doing? We are taking h of k, and see, h of n minus k was there, and you need to add from k is equal to minus infinite to infinite, and y of n will be there. Okay, so these values are there. I think I have told you here also. This all values are there, f k h n minus k. And now what we are going to see, for y of n is equal to 0, we'll see y of 0, and for y of 0 what you'll get? X of k is equal to minus infinite to infinite, x of k and h of minus k. So just you need to do what we need to do. From k is equal to minus infinite to infinite, k is equal to, see, k values are there. This all values are k only, 0 1 2 3, this values are k only. Now we need to just multiply, है ना? Only we need to multiply of x of k into h of minus k. So just and for each value, na, for each value of k we need to do it. So let's do it. See, these values are 0 into any values are 0 only. Okay, and these values are something into 0 is 0 only. Only this value and this value will be multiplied. So 4 ones are 4. So value will be 4 into 1 is equal to 4. So y of 0 will be exactly equal to 4. Simple, nothing is complex here. For n is equal to 1, what you will do? Y of 1 will do, and then k is equal to minus infinite to infinite values there, x of k is there, and h of 1 minus k is there, है ना? H of 1 minus k. So 1 minus k means we'll see here, 1 minus k is means minus k plus 1 will do, and means minus k. Actually what we'll do here, minus k and minus 1 will do. So it will come minus k plus 1 like this, hai na? So we need to just shift it. Okay, we need to, I think I'll show with green color. H of minus k was there. Actually, you need to shift only once. For n is equal to 1, you need to shift one side, because it was here n minus k was there na. So for n is equal to 1, we need to shift here. So for h of n minus k, we'll plot here. I think for all values I won't show. I will show you for some values. You can understand more after that. So h 1, if we'll shift, you'll get 1 here, again 2 here, again 3 here, again 4 here. 1 2 3 4, and here values k is equal to 1 0 minus 1 minus 2. Now see, this is your h of 1 minus k, है ना? Now what you need to do, you need, for every k is equal to minus infinite to infinite, you need to multiply xk into h1 minus k. So xk is there with you, h1 minus k is there with you, we can multiply. So we'll do multiplication. Okay, so let's do green color. See, here values are all 0 only. So whatever values are there, you'll multiply, you'll get 0 only. Only this value is there. Okay, and this value k is equal to 1, this value and this value is there. So let's multiply. 4 2s are 8, 4 into 2 8, plus here 3 value is there and here 1 value is there, 3 into 1. So you'll get 8 plus 3 11. So y of 2 will be 11. So see, the y is equal to 0 also you get. For n is equal to 2, what you will do, just what you will do, I think you will do k is equal to minus infinite to infinite, h of x of k is there, h of 2 minus k will be there. It means that this h of minus k will be there, it will be shifted by 2. Again for y is equal to 3, it will, what you are doing, actually you are shifting h of minus k to the right hand side and multiplying. How much time it will do, means till when you can do it. So up till when this value comes to the last value, when it is multiplied by this value 3, है ना, for k is equal to 3, if it is multiplied, and then after that, after when it will cross that 3 value, then there will be nothing to multiply. So whatever this value will be there, it was multiplied by 0, it will come automatically 0. So my preference will be there, because if I will tell you in video all each value, it will create so much long video. So my preference is, I have calculated y0, I have calculated y1. Okay, so it's your turn. After seeing video, you can pause it and you can just multiply it for y2, y3, y4. See after which value you are coming 0 0, and whenever your values are coming 0 0 0 0 0 0, so you should stop there and you should not take it value. So up till where the values are there, okay, non-zero values are there, till that only you'll do, and you'll find the output, and that is actually the output response of the system. So graphical method you can understand for a discrete time LTI system. Just what in very simple step in Hindi also I'll tell you. आपको करना क्या है, आपको सिर्फ xk लेना है. xn तो आपको दे रखा होगा क्वेश्चन में, आपको मान लीजिए hn दे रखा है. सो x दोनों का डोमेन चेंज कर दीजिए, एक को रिवर्स कर दीजिए और उसको आगे आगे रिवर्स करने के बाद राइट हैंड साइड शिफ्ट करते जाइए. एक बार शिफ्ट करिए, पहले एक बार भी शिफ्ट मत करिए. फॉर xk एंड h ऑफ माइनस k यू जस्ट डू मल्टीप्लिकेशन, आप दोनों को मल्टीप्लाई कर दीजिए. उसके बाद आप क्या करिए, उसको एक बार और शिफ्ट करिए, फिर मल्टीप्लाई करिए, फिर एक बार शिफ्ट करें, फिर मल्टीप्लाई करिए. एक एक वैल्यूज को आप याद रखिएगा. फॉर k इज इक्वल टू 2, k इज इक्वल टू 2, दोनों की वैल्यू जो है आपस में मल्टीप्लाई हो जाए, बात खत्म. उतनी चीजें हैं और उसकी अलग अलग वैल्यूज पे आ जाएगा. तो इट इज एज सिंपल एज पॉसिबल, nothing to worry about it. It is a graphical response, but this is not preferable for your competitive exam, because in competitive exam this much long method you cannot prefer. So we'll go for a shortcut method, and for a shortcut not for shortcut method, second method I will tell you, which method is also not preferable, but you should know. That's why I am telling you in the class. See, as you know, your delta n, okay, delta n is, if we are giving input, we are getting impulse response. So delta n basically it is an identity signal. If you can see, it is an identity signal because it's frequency domain. If you take, you'll get 1 only, na? So nothing is there. So, and whatever, if you are multiplying any signal like f of n minus n naught value is there, okay, if you multiply with delta n, what you'll get, you'll get f of okay, f n minus n naught is there, okay, and you'll get I think n is equal to 0 will get, so minus n naught will get, and delta n will be there only, okay. So whatever n minus 0, because here n minus 0 is there, so will, for n will get like this, okay. And if you are doing fn into delta n minus n naught, what you will get, you will get f of n naught, okay, because n minus n naught, whichever value is there, you can put it here, and delta n is there. This you have seen earlier in multiplication, but whenever we are convolving the two signal like fn is there, fn, and convolution with delta n minus n naught you will be there, you can directly put this all value in here. So fn minus n naught will be coming, okay. So this is your impulse convolution, okay. So see, now I'll give you some example. Fn minus n1 is there, we are convolving with delta n minus n naught will be there, okay. Now what you will do, see, fn minus n naught will be there only, है ना, fn minus n1 will be there only, but you will do minus n naught also, okay, because this value is also there. And for n we are changing, n minus n naught is there, but minus n1 is also there only, okay. So see, delta n, if convolve with delta n, you will get delta n only, okay. And whatever signal, if you are convolving like delta n minus n naught will be there, if it is convolved with delta of n, okay. So what you will get, delta of n minus n naught only. This will be treated as the signal of identity. So now, after understanding this property, now we can solve one question. We can see another method. See, this method is actual multiplication method only. Earlier we have seen the question, that is 4 3 2 1, okay. This question is there, and I think h of n was there. H of n was 1 2 3 and 4. This value is there, okay. Now what we need to do, we were doing f k h minus k and all and all. So can we write it in impulse form? So yes, okay, we can write fn can be written as 4 into delta n, because see, here we can represent as 4, here 3, here 2, here 1, okay, okay. And for n is equal to 0 1 2 3. So for here, this can be represented as sum of impulse signals. So we are doing 4 of delta n and 3 of delta n minus 1 will be there, plus 2 of delta n minus 2 will be there, and for 1 delta n minus 3 will be there. This value you can write. Now for h of n also you can write 1 of delta n will be there, plus 2 of delta n minus 1 will be there, plus 3 of delta n minus 2 will be there, and 4 of delta n minus 3 will be there. Both signals are there. What you need to do, you need to do f of n convolution with h of n. Simple. I told you, whatever signal is there, if delta impulse delta n and delta n are convolved, what you'll get, delta n only. If you are doing delta n minus n naught, see, many case delta n minus 1 is there. If you are convolving with delta n, you'll get delta n minus n naught. Just simple. If you are doing so, and I told you this also, delta n minus n naught and delta fn minus n1 convolution with delta n minus n naught, you'll get fn minus n1 minus n naught. So same method we can apply here also. So let's do it. See, first we'll do multiplication of 4 with every signal, okay. So we'll get 4 delta n cross delta n, you'll get 4 of delta n only. Next, 4 of delta n into 2 delta n minus 1, 4 2s are 8, delta n minus 1 will come, plus 4 3s are 12, So 12 delta n minus 2 and plus 4 to the 8. So 8 delta n minus 3 will come. Okay, now you'll understand here. From here I'll take this value is there. Okay, so I'll add here 3 into 1. 3 1 the 3 delta n minus 1. So delta n minus 1 will be there only, plus 3 2 the 6. So 6 is there. Delta n minus 1 was there here. Delta n minus 1 is there. So n minus 1 will be coming here and for n position. So what we'll get, see, delta n minus 1 will be there. So n minus 1 will come here and minus 1 is there. So n minus 2 will come. So we'll write 6 delta n minus 2 plus delta n minus 2 here. 6 3 3 are 9. Delta n minus 1 was there. So delta n minus 3 will come, and then 3 4 are 12. Delta n minus 4 will come. See, now what will happen, again now you need to do this multiplication with all, and then again this multiplication with all. Last what will come, this value will multiply with this value. So what we'll do, last value will calculate 1 4 are 4 delta n minus 6. Okay, so this will go on, and plus 4 delta n minus 6 will be there. Okay, so from delta n to delta n minus 6 values are there, means see output whatever may be, because see delta n minus 1 delta n minus 1 will be added and so many terms will be there. So ultimately what will be the output, you can see from delta n is equal to 0, we will get some output. Let's suppose I think 4 delta n will come. So 4 values are there for n is equal to 0, and till it will go on till delta n minus 6. So many values will be there. For n is equal to 6, 4 value will be there. So see, from n is equal to 0 to n is equal to 6, total values are there. How much values? From 0 1 2 3 4 5 6, total 7 values are there. Okay, 7 values are there which will come in output. From n is equal to 0 to 6 values are there. Okay, so I think moreover points will be there. I think 3 minus 3 6 is there, and maybe I think no values will be there. 5 and 3 3 the 6. Okay, so this will be there. Delta n minus 6 0 1 2 3 4 5 6 7. Okay, so 7 values. Ultimately see, we'll get some values. I will tell you the output. You can do it in your home, because every multiplication it will take time. So I will tell you the answer. I will tell you 4. Okay, and then 11 and 20 will be there, 30 will be there, 20 will be there, 11 will be there, and 4 will be there. This is the final output which we will get. And 2 values, so we have get here also 4 values are there and 4 values are there. This value and this value we have already got. Same, if you see in the graphical form also, we have got the output. I think 4 we have got the output, and 11 also we have got the output, and rest we were about to calculate. So you must have calculated till now, I suppose that. Now this is the output which we'll get by just multiplication. It is, I think, simpler than this method, because here every time you need to plot a graph, and then after shifting you need to multiply, and then you need to see the answer. So this is the graphical method which will take so much time. From that it will take less time, because here just multiplication is there. I think for this much values it will take hardly around 3 minutes 4 minutes. You will take just multiplication and seeing the output. So you'll get this output. What we are getting some inference or conclusion from this value will do, because in objective type of questions will get from this conclusion only. See, what is the total length? First we will see the total length. We are getting here 7, and from n is equal to 0 to n is equal to 6 we are getting total values are 7. You can count here also 1 2 3 4 5 6 7 values are there. And our input length was 4. Your impulse length was 4. So, and you are getting outputs. Total output length was is 7. So we can conclude here is that always it has been concluded by many examples, and it is true. Total length will be, let's suppose this input length will be L, this impulse response will be M, so the total length will be L plus M minus 1. Always this formula you need to remember, L plus M minus 1. So here also 4 plus 4 8 minus 1 7 is the answer. Now second conclusion, first conclusion is this, second conclusion is okay, second conclusion is, you can see the input as input was 4 3 2 1, okay, and your impulse response was 1 2 3 and 4. So whenever you are multiplying this signal with this signal, first value, because see what we are happening, what is happening here, always we are, when we are doing with this impulse values are there, so first value will be multiplied with this first value, and then it will go with second, third and fourth. So first will be delta n value only, and this is the shortest normal value. So here first value will be 4, here first value will be 1. So ultimately output is coming 4 ones are 4, है ना? So like this, whatever value will be there here, first value, here first value, both are multiplied, okay, both are multiplied, and both are multiplied, sorry, not multiplied, then output value will be, the first value will be the multiple of the lowest value, that is this value will end this value. So now it is coming 4, and the same repeats with the higher value also, because see in higher values also what we have done, we have just multiplied our signal with last value was there, last value, when we have multiplied with last value, we'll get the final output value as 4 ones are 4 delta n minus 6, है ना, 4 I think हाँ, so 4 delta n minus 6. So and here also we have seen the output as 4. So what we'll do, we'll see output also as 4, because this multiplication with this. So always whenever you are seeing the convolution of two discrete time signals, for output, for first value you need to just multiply both signals. You can check from objective if you can eliminate the options. Last value will be always multiplied with last value to get the last value of output, okay. So I think second conclusion is very much clear by seeing our multiplication. After seeing multiplication only, we could conclude this value. First value is first conclusion, total length. How much total length will be there? You can see from options. And second, you can see from just multiplication only. Like this will be there. Third conclusion was seen like this. See, when you add this output response, you'll get 4 plus 11, 15. 15 plus 20. 35 है ना, 35 plus 3 30 65, 75 85, 85 plus 11 96, and plus 4, total sum will be equal to 100 है ना. And let's see our input, 4 plus 3 7, 7 plus 2 9, 9 plus 1 10, input sum is equal to 10, out impulse sum 1 plus 2 3, 3 plus 3 6, 6 plus 4 10. So can you see sum into sum is equal to total sum? You can see it. So third conclusion is your if you see sum of resultant signal or sum of output signal, if you want to see sum of resultant signal, what you need to do, you need to do sum of sum 1 means input, and multiply by sum of output, or sorry, in the impulse, when you do sum na, means I'm taking sum of all input values and sum of all impulse values, we are doing product and we are getting the sum of resultant signal. So this three type of conclusion we can derive from our multiplication method, and this is very true, and you can just for objective type questions and seeing the multiple choice questions, you can easily eliminate some values, because if you are not having time to solve, and you by seeing only if options are eliminated, then it is very good thing. Okay, so now we'll go for third method. Third method is very easy method, and it is more suitable for competitive examination. So we'll go for our third method. Third method is tabulation method. So we'll write here as tabulation method. Tabulation method, first of all I need to tell you, this tabulation method is suitable only for when both signals are convolved having finite length. If, see, suitable only for uh, finite length signals. This is suitable for having signals having finite length. Finite length means some values are there. It is not like you are convolving un in convolution with something, and you can calculate tabulation method. This is not the thing. So you need to do, it is suitable only for finite length. So let's do it. Okay. So we'll take the same value as 4, 3, 2, 1 values are there for n is equal to 0. Convolution with 1, 2, 3 and 4 values are there. We need to convolve. So let's try it. Okay. First we'll do like this. Okay. We'll write like this, and we'll write, see, one values will do in column wise, and one values are there in horizontal wise. Okay, so any one you can keep it, no problem. So what we are doing, 4, 3, 2, 1, and here 1, 2, 3 and 4. Now what we need to do, we'll multiply this. 4 ones are 4, 4 twos are 8, 4 threes are 12, and 4 fours are 16. 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12. And then 2 ones are 2, 2 twos are 4, 2 threes are 6, and 2 fours are 8. And then 1 ones are 1, 1 twos are 2, 3 and 4. Now what we need to do, we need to make a like this line. Okay, so this line will be there. Okay, and this will go on, and this will go on like this. Values are there, and now you can write, just we need to do add. See here, 4 only values are there, 4 you can write here. 8 plus 1, 9 values are there. I think we have done, okay, we have done some mistake. I think here 3 ones are 3 was there. So 8 plus 3, 11 is there. Okay, and then 2 plus 6, 8, 8 plus 12, 20. So 20 is there. And now 4 plus 1, 5, 5 and 9 is there. 5 and 9, 14 is there. 14 plus 16, 30 is there. So 30 you can write. And then 2 plus 6, 8 is there. 8 plus 12, 20 is there. So you can write 20. 8 plus 3, 11 is there. And you can write 4. So you can see the output, basically what we have got earlier as output. You can see here 4, 11, 20, 30, 20, 11, 4, and the same values we have got here also. So I think by graphical method you'll solve so much and you'll get this value only, but for means conventional you should do that only. For multiplication method you need to multiply but after multiplication only we could got this conclusion, which is very useful for objective type of questions. And for tabulation method you can do just simple method, and you need to convolve and you need to multiply and then add. So this was tabular method for getting the response of a discrete time LTI system. Okay, so after seeing all this discrete time LTI system, and we have seen some of the questions. So one question you must see because we have seen the sample values. So seeing the sample and discrete values, if we are going for a some type of signal that is a n un, so let's try to see this value. Okay, so question is there, if your input is f of n is equal to a of n u of n will be there. Okay, and your impulse response will be there. Let's suppose response impulse response is your u of n minus k will be there. Okay, Okay, so I think this value is there, or you should not go like this, and you should go for u of n only, not n minus k, because we'll do after it. So un, okay, a n u n will be their input, and un will be the impulse response. Now you need to calculate output. What we'll do mathematically only, because by graphical method, by everything, it will take so much time. So for normal method, mathematical, we'll do, as you know, for getting any output, what we'll do k of minus infinite to infinite, your f k will be there, and your h of n minus k will be there. This is your uh, true convolution from mathematical point of view. So what we'll do, we will apply here, like suppose from k is equal to minus infinite to infinite, fk is your a of n, u of n will be there, na? So we'll do a of k, u of k, okay, and h of n minus k is there, so h n is u of n, so we'll do u of n minus k will be there. Simple. Now you can see what we are doing. We are going for a k and u n minus k is there. U k into u n minus k, how it will come? See, when we are going for discrete, let's suppose this is k domain, and we are plotting uk. So uk's values are like this only, and it will go on, this is u of k, okay, and u of n minus k, how will plot? See, this is there and this is there. U of n minus k means, first we need to, it is in k domain, na? So what we need to do, first we need to rotate, means across y axis, time reversal, and then we need to shift. So u of minus k, you have plotted u of minus k. If you will plot, you will get this value here, and this value here, here and here, and this go on. And then you will plot here, I think k u of n minus k means, for every n is equal to 0, sorry, for every n value till, let's suppose n is equal to 3. So till 3 values are plotted. Let's suppose n values something. So for n values, it has been shifted, okay. So it has been shifted, but earlier it was till here only, it has been shifted. So let's suppose this is your n minus k, u n minus k. Now what you will do, you need to multiply uk into u n minus k, you need to multiply. So you know that these values are 0 and these values are something, so multiply, it will come 0 only. So from k is equal to 0 till k is equal to n only, whatever numbers will be there, you can multiply with this value. After this, whatever value will be there, multiplication, it will come 0 only, है ना? So the values are from 0, k is equal to 0 to k is equal to n. These values are only multiplied, or this value only exists. So can we do, we should not go for minus infinite to infinite, we should go for k is equal to 0 to n, and your signal was there, ak was there, and ak was there, and multiply, whatever you'll do multiplication, you'll get 1 into 1, you'll get 1 only, hai na? So you'll get 1 only, nothing problem is there, so you'll get 1 only, okay. So okay, we'll not write here. Now this is your value. So here from k is equal to 0 to n, okay. Okay, I think we have I think okay, so we'll put values from here. A is equal to 0 plus a is equal to 1 plus a is equal to 2, and so on till a is equal to n. So this will be 1 plus a square plus so on, and as you know the formula, so we'll go for 1 minus a, okay, to the power n plus 1, and here we'll go for 1 minus a, okay. This gp values you already know. So this will be the answer for n is greater or equal to 0, and this will be your final output. So see, you can also write it like this. For n is equal to 0, you can write it as u of n, okay. So this is your output of when we are doing a n un convolution with u of n, we are getting this type of answer. So see, out in 4 methods I have told you how to convolve. This type of problems will be solved by this mathematical expression only, mathematical thing. And then what we are doing, like this samples are there, you can do tabular method for easy shortcut method. And it is not suitable for infinite length signals. And then conclusions we have seen, and multiplication method is also we have seen, and the graphical method we have also seen. So this was it from me for this lecture. We'll meet in lecture 3 with in module 2 only, with continuous time LTI systems. And then we'll see, when we are already we have seen continuous time LTI system how to solve, and then we'll see the properties of both systems. So till then, take care, be safe. So please like, share, and do comment for if you are liking this video, and support us, share with those students who are in need of this type of classes, which is of free of cost. Almost we are taking out time from our busy schedule, and we are making this lecture. So please share it. So okay, tata, bye bye, see you, have a good day. Okay, Jai Hind, Jai Bharat.